Hey guys, here is your section 6.7 day 1 notes. We are starting to solve radical equations. So first, I need you guys to remember how we solve equations. We solve equations by using opposite operations, right? We have to undo what the equation is doing, okay? So for example, if you had to solve this equation, x plus 5 equals 12, well, if they're gonna add 5 to x, we're gonna do the opposite of that and we're gonna subtract 5. Because that's the opposite of adding 5. We're going to undo what they're doing, right? And then x would equal 7. Done. All right? If they're going to say 2 times x equals 20, well then to undo that, I'm going to use the opposite of timesing by 2, and I'm going to divide by 2 on both sides. So then that cancels, and x is equal to 10. That's how we solve equations, right? We use the opposite operation of whatever operation the equation is using, right? Okay, well remember, roots and powers are opposite operations. A root and a power should undo each other, right? So look here, if I said to you, what is the square root of 16 squared? Well, guys, we do inside parentheses first, right? So the square root of 16 is 4, and then it says to square it, 4 squared is 16. I'm left with the exact same number that was under this radical because guess what was actually happening? When you take the square root of something and square it, those are actually canceling each other out and you're just left with the number underneath anyway, because that's what roots and powers do. If it's the root and power are the same, they're gonna cancel each other out. Look at this one. What is the third root of 8 raised to the third power? Well, technically we would do inside first. The third root of 8 is 2. 2 to the third power, 2 times 2 times 2 is 8. So again, you're left with the same number that was under this radical, because essentially what was this third root and this power of 3 doing to each other? They are canceling each other out and just leaving you with the number underneath, okay? So in the future, if you have the square root of x squared, what is this root of 2 and power of 2 going to do to each other? They're going to cancel each other out, and you're going to be left with just x. So if you ever have to get rid of a square root, then square it. That power of 2 will get rid of that root of 2. All right, look at this one. If you have the third root of x raised to the third power, then what is this third root and that power of 3 going to do to each other? They're going to cancel each other out, and you're going to be left with just x. Okay, so if you have to undo a third root radical, raise that radical to the third power, and they'll cancel each other out. All right, if I have the fourth root of x raised to the power of 4, well then what is this root of 4 and power of 4 going to do to each other? They're going to cancel each other out, and you're going to be left with just x. So if you ever have to get rid of a fourth root radical, just raise it to a power of 4 and they will cancel each other out. So we're going to have to use that when we're solving radical equations. If you have to get rid of a radical or a root, then you're going to have to use powers, okay? So here are your solving steps so you can look back and make sure you're doing the correct work. First things first, if you want to solve a radical equation, you have to get the radical alone by itself on one side of the equal sign. So get the radical alone by itself first. I cannot stress that enough. A lot of students want to jump the gun and they start bringing in these powers way too early. Get the radical alone first. Then once the radical is alone, you're going to want to get rid of the radical by using some power. So then you're going to raise each side of the equation to the needed power. What power do you need to get rid of that radical? Okay, if it's a square root, you'll need a power of 2. If it's a third root, you'll need a power of 3. If it's a fourth root, you'll need a power of 4, and so on. All right, and then you can solve the equation for x. Okay, all right, let's go through some examples. Let me try and see if I can leave that on the screen while I do the first example. Okay, so look at the first example. Solve this equation for x. Well, step 1 is get the radical alone. Well, guys, this is the radical, so we have to get him alone. So this plus 6 has to be away. So how do I get rid of the plus 6? I subtract 6. Standard solving equation rules, right? So then I'm going to be left with the square root of x equals 8 minus 6, 2. Well, there it is. The radical is completely by itself. So now I want to get rid of that radical by using the needed power. Well, what power do you need to get rid of a square root? You need a power of 2. So raise both sides to a power of 2. Because whatever you do to one side, you got to do to the other side, right? It's all about keeping the balance. All right, what does this power of 2 do to that square root? It cancels it, and you're left with just x, okay? And that's going to equal, well, what is 2 raised to the power of 2? 2 squared is 4. All right, and then the last step says solve for x. Well, lucky for us, just by getting rid of that radical, x is alone. We have solved for x, and x must be 4 to make this equation true. So you're done, and the answer is 4. Okay, let's try another one. All right, look at this one. Step 1 says, get the radical alone first. Well, guys, if you look at this side of the equal sign, the only thing that's on the left side of the equal sign is this radical. X minus 2, they're all stuck under this radical. So I can't get to any of these until I get rid of this radical. So technically, the first step is already done. The radical is alone. All right, so step 2 says, raise each side of the equation to the needed power. Well, what power am I going to need to get rid of this square root? I'm going to need a square. I'm going to need a power of 2, right? So square both sides. And now this square and this square root cancel each other out, and you're left with x minus 2. They're free now. They're not under a radical anymore. Equals 5 squared is 25. All right, and then the last step says solve for x. So x isn't alone right now. Now I can physically start getting x by itself. So now I'm going to add 2 away. And in order to make this equation true, x is going to have to be 27. And you're done. Okay? All right, let's try another one. Okay, look at this one. We have to solve this equation for x. Well, right now, x is stuck under this radical. I can't get to him, right? So I'm going to have to get rid of this radical in order to get to x. But I'm not ready to get rid of my radical because my radical's not alone first. This 4 and this 10 are not allowed to be on the same side as this radical. I have to get them away to get this radical alone because they're not under the radical. So what do I want to move first, the 4 or the 10? The one that's attached or the one that's not attached? Well, standard solving equation rules, we get the one that's not attached away first. So I'm going to minus 10 from both sides. And that's going to leave me with 4 times the square root of 3x minus 3 equals 46 minus 10, 36. All right, now let's get the 4 away. The 4 is attached by multiplication, so I have to divide him away. All right, so that's going to leave us with the square root of 3x minus 3 equals, what's 36 divided by 4? 9. Okay, now, if you notice, the radical is alone. So now, what power do I need to get rid of this square root? I need a power of 2. So now, I can square both sides. All right, so what does this square do to that square root? It cancels it, and I'm left with 3x minus 3. Let me go over here. 3x minus 3. And now that's going to equal, what's 9 squared? 81. Okay? All right, now you're back to solving just a normal equation. Now you can solve for x. So add 3. And you're going to get 3x equals 81. I'm sorry, 81, sorry, 84. All right, and then last thing we have to do is divide by 3. And x will equal 84 divided by 3 is 28. And you're done. In order to make this equation true, x has to be 28. And you can plug it back in and check, and you'll see that it's true. Okay? All right. How about this one? All right, the square root of 2x plus 5 and then minus 8 equals negative 5. Well, our job is to solve this for x. The problem is x is stuck under that radical, right? So I'm going to have to get rid of this radical at some point, but I'm not ready to first. First, you have to get the radical by itself. So add the 8 away because he's not under the radical. So now I'm going to get the square root of 2x plus 5 equals 3. All right, now the radical is alone, so now I can get rid of it. So what power do I need to get rid of a square root? A power of 2. So raise both sides to a power of 2. And what is this power of 2 going to do to that square root? It's going to cancel it, and you're going to be left with 2x plus 5 equals 3 squared is 9. All right, and now you can solve for x. So minus 5, 2x equals 4, divide both sides by 2, and x equals 2. X would have to be 2 to make this equation true. Okay, again, one of the biggest mistakes I see with students is that they try to square both sides before they get the radical by itself. You have to have the radical alone before you can raise it to some power, okay? All right, a couple more and we'll be done for today. All right, look at this one. Our job is to solve this equation for x, but right now this x is stuck under that third root radical. So first, get the third root of x by itself. So this 4 and this 2 that are on the outside of this radical have to go away. All right, so first we'll move the 4 away, like always. All right, and then we'll have 2 times the third root of x equals negative 4. Divide both sides by 2. And now you get the third root of x has to equal negative 2. Now, I don't want to get too technical, but right now, you're taking the third root of some number that we don't know, we're trying to find out, and it has to equal negative 2. Well, can the third root of some number equal something negative? Yes, remember, you can take the third root of a number and it be a negative number because something times itself 3 times can end up negative. If this was a square root though, could the square root of some number equal a negative? No. So just be careful. You shouldn't run into any of those issues. I don't think Delta Math is going to assign you anything like that, but I just wanted to kind of make that a point that if you took the square root of some number and it was negative, then that's not a real number answer. That would be an imaginary answer or no real solution, okay? All right, just to kind of point that out. All right, well, now we're here. So what power do I need to get rid of this third root radical? I need a power of 3. So now I'm going to have to raise both sides to a power of 3 to get rid of the radical. All right, so what does this third root and power of 3 do? They cancel. I'm left with just x, and it equals what's negative 2 to the third power? Well, again, you can ask your calculator if you're not sure. Just make sure you put negative 2 in parentheses, and then raise it to the third power, hit enter, and the answer is negative 8. Okay, so x would have to be negative 8 to make that equation true. All right, look at this equation. The fifth root of 4 times x plus 5 equals 7. All right, so here's your radical, and there's x. He's stuck under it, so I can't get to x until I get rid of this radical. But first, I have to get the radical alone. So minus the 5. Okay, and then the fifth root of 4x is equal to 7 minus 5 is 2. Okay, well now, the radical is alone, so what power am I going to need to get rid of this fifth root radical? I'm going to need a power of 5. So raise both sides to a power of 5. So now what does this root and power of 5 do to each other? They cancel. I'm left with 4 times x, and it equals 2 to the 5th. If you don't know what 2 to the 5th is, take 2, raise it to the 5th power, hit enter, it's 32. All right, and then last, now you can solve for x. Divide both sides by 4, and x equals 8. Okay? All right, last one. All right, so negative 2 times the third root of 2x plus 5, and then plus 7 all has to equal 15. So our job is to solve this for x, but right now, x is stuck under this radical. I can't get to that radical until that radical is alone. So negative 2 and 7, they gotta go. Which one goes first? The 7. Okay, so negative 2 times the third root of 2x plus 5 equals 15 minus 7 is 8. Now I get the negative 2 away, so divide him away since he's attached by multiplication. And now you are left with the third root of 2x plus 5 has to equal negative 4. Okay, so what power am I going to need to get rid of this third root radical? I'm going to need a power of 3. So raise both sides to a power of 3. All right, so now I'm left with 2x plus 5 equals, what's negative 4 to the third power? If you don't know, put -4 in parentheses, raise it to a power of 3, hit enter, and it's -64. Okay, now we can finish solving. So now, -5, I get 2x equals -69, divide by 2, and now x equals -69 does not divide by 2, right? So since you can't divide it, you can look to reduce it, but it doesn't reduce. So your answer is just -69 over 2, -69 halves, or it's -34.5 as a decimal. I'm not sure which one Delta Math is going to want. They might want the fraction, so just pay attention to what they ask you or how they ask you to write your answer. Okay? All right, so that's the first day of solving radical equations. So if you have to get rid of a radical, you're going to need a power. Okay? But just please remember to get the radical alone first. That is the #1 mistake in this section. All right, your homework will be on Delta Math. Good luck, and as always, reach out to me if you have any questions. I will always be here to help you. All right, good luck.